red button there?
Yes, it's good.
It's recording.
Okay, here we go. We have 3 new equations for you to learn today. The first one is right here, the range equation. Range is how far away something would land. Okay? If I'm a center fielder and I want to throw the ball to the catcher, the range will be how far away the catcher would be. Okay, wherever it hit the ground first. If I'm a shot putter, range would be where it's going to hit the ground. Okay, anywhere it's going to be the horizontal distance away that the object is going to hit. Alright, and the way you're going to do that is range is equal to velocity squared times sine of the angle doubled. This is not a 0 here. It's not sine of 20. It's sine of 2 times theta. That's not 0, that's theta. Okay, you might say theta. Okay? And that is the angle, which we already saw this when we did SOHCAHTOA. That's the angle. Okay? Divided by g, what's g always equal to?
10.
10. So, why don't we practice one now? If we had a velocity of, I don't know, 15 meters per second, an angle of 35 degrees, go ahead and figure out how far away it will land. And pause.
It's not recording.
You good?
I didn't hear any beep
It's
before.
recording. I can see the button.
Okay. Yeah.
That should be on.
That's going to be on there now. Yeah. See? Okay.
That should be on CNN.
Hey, this
Velocity is
not
15. So it'll be 15 squared. Sine 2 times 35. If you have a crappy Casio, you don't get the parentheses when you hit sine. So you need to do that yourself. You need to, as soon as you hit sine, open a parenthesis. If you have a TI something good, you'll get the parenthesis already. Then you close parentheses divided by 10. Okay?
21.14.
21 point something something?
14, 21.
15 squared, sine open parenthesis. So basically that's the same as saying sine of 70, right? Because you're going to double the angle. You have to be careful that you have parentheses. 21.14. Or 21. Huh?
We both got the same answer.
And it was wrong?
Yeah.
Okay, let's pause here. We'll pause for station identification. Okay.
World.
Or one example of this would be mortars. Okay, if you've ever heard for military stuff, they talk about mortar. The U.S. bases under mortar fire. A mortar is kind of like, I'm not an expert with saying, but it's kind of like a grenade launcher kind of thing, where they have this little tube and you drop it down and it fires off. Okay, and the idea with that is the same thing, where the only thing you can change, the velocity is set. Okay, you drop it down, it's going to shoot out a certain velocity. But if you change the angle, it's going to change how far away it lands.
Yeah.
Okay? What angle would get you the farthest distance?
45.
45 degrees. If you ever want to get something to go the farthest distance, you will have to throw it at 45 degrees. Okay, that has to do with pumpkin chunking. Okay? The center fielder throwing it trying to get it to the catcher. The shot putter, he's going to have to make sure he's firing at or throwing away at a 45-degree angle. Okay? Anything where you want to get something to go the farthest distance, it has to be thrown at 45 degrees. Okay? And the idea is that if you had 0 degrees, the ball would never actually be in the air. Okay? There's no angle, so it would be immediately hitting the ground. And yeah, it would roll, but we don't count the roll part. It wouldn't go very far after rolling anyway. Okay? If I went 90 degrees, it would go straight up and straight down. Again, the range would be 0. So 0 degrees and 90 degrees, the range is 0. So that happy medium, where you get a little bit of horizontal velocity and a little bit of vertical velocity, so it'll be in the air for a while, but also have a certain speed to go, is going to be 45. Okay, so anytime you hear the term maximum range, that means make theta equal to 45 degrees. You know, and I'm sure if you ask Coach Bailey about shot put, he's going to tell you that the shot putters have to practice throwing at a 45-degree angle, because if they are doing here, throwing it straight up, it's not going to be very useful. If they're doing it here, it's not going to be in the air long enough. They went 0 degrees. They need to practice that angle, that 45 degrees to go off at. Okay? Even with wrestling, I have my guys, if we don't want to throw guys straight up in the air, we want to get some drive at an angle. And I tell their leg to be at 45 degrees to drive off. Okay? So if you might see a question where it just says maximum range. Okay? And it gives you velocity. You have the angle. You'll be given the angle in the...
Camera is not working.
We're good. Okay. All right. So, if we have the same velocity and the same angle, and now we want to figure out time, it'll be 2 times 15 times the sine of the angle, 35 degrees, divided by 10. And
1.72.
1.17,
2.
72.
1.7.
Wait, let's see the money.
1.72.
Good, ¿qué pasa?
1.72.
Cool.
I
Huh?
have 1.72.
1.8.
That's how it's calculated.
You must have a crappy Casio.
That's not a correct calculator.
I'll look in a second. I'll go look in a second. Okay.
1.72.
Next up is the height equation.
I got 1.72.
Do that stuff there, so you did.
All right, go and copy that down, and then I'll talk about how to do it.
Did something mess up?
And we'll pause.
He messed up.
We're good? Okay. All right. This is the ugliest one, and this is one you really have to be careful about your parentheses. And I'm going to show you how. This is how, if you have a crappy Casio, this is what it should look like. Okay? A TI will give you a little bit of a shortcut if you want to. The velocity squared, we know how to do that. Okay? Then, what the idea is that you're taking the sine of the angle and squaring that. Okay? You're not squaring the angle and then taking the sine of it. You're taking the sine of the value, then square. Okay? So, and then divided by 2g. But what's 2g always going to be equal to? What's g always equal to? 10. So what would be 2g always equal to? 20. You might just want to write 20 down. Okay? We know it's g, we know it's gravity, but you might just want to put down 20. Okay? In your TI, if you have a TI and not a crappy Casio, you can replace these two parentheses with just that one there. If you have a TI and not a crappy Casio. Okay? Because a TI will know.
Now it's
Recording.
Say it to go.
So we got 3.7, velocity is 15, angle 35. Just to recap for if it wasn't being filmed. If you don't have a crappy Casio, if you have a better calculator, you could just have these two blue parentheses. You wouldn't need the black parentheses. Okay? Now, while you're doing your worksheet, now that we can edit this on video, you must show all your work to get credit. I will have the answers posted. Even if you're plugging it into your calculator, you're going to write on the paper how it looks in your calculator. That will help you down the road when we have these same problems but the numbers have changed. Okay?
That's it?
That's it.
You can record.
We can stop recording.
That's a
Bye.